Yeah, thanks for the introduction, and yeah, also welcome from me to the first installment of the TRL seminar in this year. And as you mentioned, I'm going to present this recent paper. Can we maybe move the yeah, the paper that I worked on together with Madelon and Cornelius and presented at Europe's named Are We Asking the Right Questions on Ambiguity in Natural Language Queries for Tabular Data Analysis. And the basic setting that we're looking at in this paper is one of open domain tabular data analysis, where we have a large corpus of tabular data, something like a data lake or just a big repository of tables, and users that have some sort of latent insight need. So like a concept of what they want to get out of that data. And a lot of research has focused on building like this connecting block in between some system that can do open domain tabular data analysis. And what these systems usually do is they accept some sort of natural language input query from the user and then produce an output that at best should satisfy the insight need that the user has expressed. One thing that we realized while we're looking into these systems is that they usually work with natural language, and one persistent feature in natural language is ambiguities. They arise at pretty much every point with the natural language. And I want to start this off with this very easy to understand example. What's the average temperature in Amsterdam in January? I think everybody here has a very good understanding what someone that asks this question wants, but there's still quite some ambiguity. For example, what does average actually mean? Should we report the arithmetic mean or the median? Also, which time span to aggregate the data over? And also, what Amsterdam? Is it the capital of the Netherlands or Amsterdam in California or one of the 12 other villages called Amsterdam in the US? And what many works that look into ambiguity do is they treat it as a deficiency of queries and something to fix. And in this talk, I want to shift the focus a bit into seeing it more as a natural feature of language. And to that end, I want to answer 3 questions. First, why do users actually formulate such ambiguous queries? How should systems and evaluation handle these ambiguities? And lastly, also, are the evaluation data sets that we're currently using actually measuring what they claim to be measuring? So the underlying premise of our argument here is that users cooperate with systems in the same way, or like in a similar way that humans cooperate between each other, meaning that we can apply the same sort of logic into how natural language is used, meaning that we can invoke Grice's cooperative principle and mold it to this application. We can say that there's like 2 defining rules that govern these natural language interactions, which is first the maxim of quality, that the users are truthful in what they are expressing, and the second is the maxim of quantity, that users provide sufficient but not excessive information. And this is like very important in this setting to interpret the absence of information as well, because users are very deliberate about the amount of information they convey. Given that, we say that users that follow this cooperative principle, they formulate cooperative queries, and these queries allow discriminating if any given interpretation of the query is actually aligned with the user intent. So what do users now expect a system to do with ambiguities? We argue that there's basically 2 different modes of interpretation that a user may want a system to apply to ambiguities. And the first of them is to apply conventional grounding, to just assume the the most likely option when there is a convention on a certain term. For example, that is the case for Amsterdam. If there is no further specification, a person would usually refer to the capital of the Netherlands and not some small village in the US. The same goes for assuming the arithmetic mean for the average, but slightly differently. Or like the second category is that the user may expect the system to apply selective grounding, meaning that the system should actually make a good decision by itself, which we argue is sort of a division of labor, where the user specifies some parts of the analytical process and leaves other parts open for the system to interpret itself. And this is the case for choosing a time span. And if you think about it, this makes a lot of sense, particularly in this open domain setting where users are not aware of the exact data that is underlying. So it makes a lot of sense to let the system decide which time span to actually choose instead of defining them upfront. But there are also cases where we cannot apply conventional or selective grounding. And that is always the case when users violate the cooperative principle. And we term queries like that uncooperative queries. And an example of that is, what is the average temperature? Where the big question is, what location does this refer to? Without any, we are not given any indication on which location this refers to. So we cannot make sure that any interpretation is actually aligned with the user intent. So putting these things together, we have these uncooperative queries which don't really have a mapping to any interpretation, whereas these cooperative queries map to a set of interpretations that are possible from them. And thinking about evaluations, what can we use these queries for? There's actually use for both types of these queries. These uncooperative queries can be used to test robustness towards unanswerable queries. And the cooperative queries can be used to test whether the systems actually make good grounding decisions and interpret queries in a way that is actually aligned with the user intent. But that is not what benchmarks are claiming to do. Benchmarks try to usually evaluate for execution accuracy. And that can only truly be tested with queries that have just a single interpretation, because otherwise there would be multiple valid interpretations of that. So we can basically just use a subset of the cooperative queries, which are truly unambiguous, to test for execution accuracy. And so we would assume that the popular benchmarks that are out there mainly consist of these unambiguous queries. So what we did is we looked into 15 popular benchmarks from a few different domains, from tabular question answering, but also text-to-SQL, and looked at them, we assessed the share of unambiguous queries that is actually captured within them. And you can see the datasets down here, and the share of unambiguous queries of them is below 50% of queries for almost all of the datasets. So the vast majority of queries are actually ambiguous, and what we are evaluating is basically a mixture of how the system interprets queries and how accurate the system is in executing on those. So we do not really isolate the capabilities. With that being said, I wanted to conclude with a bit more of a positive outlook. What should we take away from this? First, let's build better systems, better datasets. We should make ambiguities explicit in existing and in new datasets. And we should also build datasets that are with which we are actually able to evaluate whether these interpretations are in line with user intent. Second, we also should build better systems, ones that are empowered to take the lead in steering interpretations of queries, and also going beyond single-shot interactions towards more cooperative interaction between systems and users. So yeah, thanks for the attention, and happy to answer questions. Yeah.
Thank you for the presentation. You showed this slide earlier, or like three slides ago, with this ambiguity benchmark. I see for BERT, is it 25%? Unambiguous questions?
It's only 50, but
50,
one caveat that I have to mention here is that we look at these benchmarks through the lens of open domain evaluations, which means that like the regular text-to-SQL setting where you're provided with the data as context is slightly different. So this is from an open domain perspective.
Maybe you can actually, are you familiar with the open domain setting?
No, I would probably, is it your paper? Yes. It's a graphic, I probably have to read this because I would be curious in how to detect these, because we are also doing benchmarking with things like BERT, and we are aware that there are questions that are very ambiguous. So it's like you can get to 80% with something that should practically get to 100. So there is something that is it seems off, but I also saw this paper from Cider this week, which said BERT has like around 50%. So they seem to be different numbers, and I'm just curious what the different basically mechanisms or techniques are to detect ambiguous questions.
So what we did for this detection of ambiguity is we defined different categories of what needs to be defined within a query. Like the most basic breakdown is into procedural specification and data specification. So is the procedure that should be applied to the data fully specified, and is the data that needs to be selected fully specified? And we broke it down further and then used an LLM judge approach to evaluate queries from these data sets, which was then also verified by human annotators.
Okay. And second point, if I may, is just it's more like a remark to the last slide, or like I think one or two further where you the takeaways. Yeah, with the conversational analytics, and it seems like it's a good next step, because one-shotting is maybe one-shotting a good question is also not easy for the human user.
Yeah, like I think we make this argument that users formulate these cooperative queries, but I think in reality many users are also just a bit lazy. They don't really think about everything upfront. So I agree. Like I
can talk about like an interesting anecdote. I talked with a company they were building an analytics agent platform basically, and they said they have customers that only use this basically for the business users to chat with this thing until they have actually specified what they want. Mm-hmm. And when that is clear, they send the question to the actual human analyst to answer it. So it seems to be like a really big task actually to get this information from the user. The other thing is in this conversational, you said it's a conversation with the user, right? But I feel with agentic system, it can also be a dialogue with the LLM itself that leads to things, and things are unambiguous. So I think that's also an interesting aspect to look into.
Yeah, I think in that direction is also, I mean, with the talk we had in the seminar before the winter break, where I think Irina also talked about the fact, or like her projects on presenting different paths, like to resolve ambiguity and presenting users with these like different ways of specifying or further specifying a query. And I think that might be a good way to aid users in navigate that.
Right, and what I mean with if you have the agent, then as well, which has access to the data, sometimes I think ambiguities in a question resolve themselves when basically when the agent gets more information from the data that's actually available. Then it might become clear which city this user means, if there's only one in the data set, for example.
But that only applies if the user also knows the data, because otherwise you cannot really make this connection. At least the user has to have some sort of idea of what data they're more or less accessing.
Yeah.
Maybe we can take one more question from Jan Christel.
Do you think you capture all ambiguities with this? Because it's. Do you have a breakdown per category? And do you only have categories that are focusing on words and ambiguities in words?
No, okay. So let me quickly switch the slide. This is a bit more detailed, but not fully detailed. This is disaggregation on this procedural and data level. This is a bit difficult to read because basically the result is the smallest. Doesn't matter. So the way we construct, or the way we approach this is by thinking about follow-up questions that you would have to ask for a question, for a query. And basically, is there any follow-up questions that are needed or possible or not? So we try to just go beyond finding things that are captured within the query, but also.
But that's what the LLM does, or what you do manually?
That is what the LLM does.
Okay.
Yeah.
Do you think that isn't there? Okay, I think that there is maybe no unambiguous query if you have natural language.
Yeah, exactly.
Every time I write a database exam and I let my students write SQL queries, they come up with some solutions like, yes, that makes sense.
Yeah.
I've never thought about it. This is 1 in 200 student solution, and I have to give them points for something that I never would have come up with.
Yeah. No, I think that is a great point. And actually, one thing we also thought about a lot, which is that in this ideal world where users would be truly unambiguous in everything they say, they would have the perfect model of what needs to happen and what data needs to be there.
They won't write a SQL query.
So
and not natural language question.
Yeah, exactly. Something like that. Something very concrete. But yeah, I think that is not really possible within natural language.
We call them platonic queries also for that reason.
Yeah. So, and these unambiguous queries that we're looking at here are maybe the closest thing. But yeah, it's not. Yeah, the thing is that there is no sharp boundaries here. I think it's also oversimplified a lot, but yeah.
Maybe we can discuss that over drinks after. But thanks, Daniel.